Okay, a quick look at the sublimation of dry ice. We call it dry ice, but of course it isn't normal ice, right? It's not water ice. Dry ice is actually this stuff, CO2, is carbon dioxide. Now, you know about carbon dioxide because your body makes it and we breathe it out. And the plants are like, awesome, thanks. And then they give us some oxygen in return. So it's a win-win. However, carbon dioxide is usually a gas. That's how we all know and love our carbon dioxide, or actually in the case of climate change, not loving our carbon dioxide because we're pumping too much of it into the atmosphere. But anyway, it's usually a gas. This dry ice, on the other hand, is actually a solid. Silly carbon dioxide, why would it be a solid? Well, probably because it's minus 78.5-ish degrees Celsius. That's massively cold, right? So cold that that gaseous CO2, the gaseous carbon dioxide, is actually solidified and is a solid. Now, when it warms up, it's going to turn back to a gas, okay? That's this whole thing called sublimation, right? When things sublime, sublimation. What this means is that they turn to a gas straight from a solid, right? If you remember your states of matter, the first three states, we've got solid, liquid, gas, and we can quite happily go from one state to another. We can melt our solid, or we could freeze our liquid, we could evaporate our liquid, or we can condense our gas. Yeah, that's cool. Well, sublimation is actually change color for it because it's a special guy. Sublimation is this one, going from a solid straight to a gas. There's actually one more, I may as well throw it down as well. The other one, going from a gas straight to a solid, is called deposition, right? That's what snow does. Deposition forms snow. Snow deposits around a deposition nuclei. It doesn't form a liquid first and then freeze. No. Anywho, we're talking about CO2, not snow. So CO2, frozen CO2, when it's really, really massively cold, it's a solid, but it will turn back to a gas. It will not melt first. It will go straight back to a gas, so it bypasses the liquid phase, right? Now, this stuff being so cold means we need to be careful with it. If you ever find yourself in the position where you're having a bit of a play with dry ice, you do need to be really, really careful because cold stuff will burn you, all right? It's not just hot stuff that burns, cold stuff burns as well. And this is very, very cold. It will damage your tissue. So you do not hold on to it. If you were ever needing to pick up a piece of dry ice, you would, of course, keep it moving around in your hand. You wouldn't just let it sit in the palm of your hand, because you get burnt. Right, so what happens when you put dry ice into water? Well, we get a whole lot of, looks like smoke. Essentially, it's fog. Let's have a look. Blow on it, Declan. Oh, that came out and then up.
Tallest to smallest.
Okay. Ailish to 10 then. Let it build up. Declan, stop. Let it build up for Ailish. Okay. Do it again, Ailish. Go.
Like that.
Hang on.
You can, when you blow it
Go again.
completely.
Okay, so what did we actually just observe there? Well, we had some water in a container. We had some chunks of dry ice on the bottom. Now, it kind of looked like it was boiling, didn't it? It wasn't actually boiling. It was just normal tap water from the tap and wasn't over a Bunsen flame or anything, was it? But that dry ice was bubble, right? It was bubbling away. There were bubbles coming up, some rather large bubbles, in fact. Because remember, the dry ice, that solid CO2 was subliming. It was undergoing sublimation, so it was subliming. It was turning straight back to a gas. So there we go, a gas being less dense than the water, it comes up. So it did look like it was boiling. It was actually, the dry ice was subliming. But the smoke, what was all that about? Well, the water was being cooled down. And in fact, at the end, I put my hand in the water, and sure enough, it was really, really cold. But the water in the air, the water vapor, was also being cooled down and was actually condensing to form these tiny, tiny droplets of water. Essentially, it's a cloud, right? That's what clouds are, little water droplets. So we were making a cloud or a fog. I mean, a fog is essentially just a cloud that's hanging really low, right? So that's really what we were making. Essentially, by putting the dry ice in the water, we made some clouds or some fog. That's what that white smoke was, which is quite fun to blow around. Now we'll take a quick look at something else we can do to play around with dry ice, and that's make it scream for its life. Let's have a look. All right, push it down, guys. That's it, Ken. Good job. You can use it now. Yeah, turn the knife over, Ken. Try the other side. Okay, stop. Goodness, I don't know who's just making noise. So one at a time. Alice, you first. Ken, go. Alice, go. Ken, go. Try the tip of the knife at the end. Yeah. Move your hand away from the dry ice. Don't touch that. Right, ready? Wait. Together. Let's see how much noise we can make. 3, 2, 1, go.
Hang on.
Oh my goodness, that was loud. Okay, so what was going on with that? Right, well, here we have a piece of dry ice. There we go, CO2 solid. That is our dry ice. Now remember, it's subliming. It's turning back into a gas. It does this from all around the dry ice. So this stuff on the side here, that's turning into a gas. This stuff over here, that's turning into a gas. Underneath, that's turning into a gas. On top, that's turning into a gas. And that's the key point. That stuff on top turning into a gas. Because when you place something like flat and metal across it, like the blade of a knife, there we go, well, the dry ice is turning into a gas, and that is pushing upwards on the blade of the knife. Okay, and that makes the knife blade vibrate. What happens when something vibrates? We get sound, all right? When you speak, you want to make some sound, we vibrate our vocal cords. Maybe you like playing music, so you strum your guitar string. Yeah, the string is vibrating, so we're making sound here. If you want to make a noise, make something vibrate. So there we go, the dry ice was turning into a gas and was pushing up on the blade of the knife and making it vibrate. So we get that noise. Not necessarily a nice noise, it's not really a nice sound, but it was definitely a noise. Now, this whole gas given off and pushing against something, like in this case it was pushing against the blade of the knife, we can use that for another we play with dry ice. Let's take a look. Ken, be careful, do not touch it. All right, now the explanation of this one was pretty similar to the explanation of the previous one. Here is our solid CO2, our what we call dry ice. Now, in this case, it was actually sitting on a table. There we go. Now, remember that dry ice is converting to a gas. So here it's going to a gas, and here it's going to a gas, and the top gas, that's why it vibrated the knife blade when we pushed down on it, and here it's going to a gas. But remember, underneath the block of dry ice, well, a very small piece of dry ice we had, it's also turning into a gas, and that is going to be pushing against the table. Now, when this, I'm turning into a gas was pushing against the knife blade, it was able to vibrate the knife blade. It could push it upwards. Well, the table's a lot bigger. And where has it got to go? It can't be pushed down because the table's sitting on the floor. So rather than the table being moved away from the dry ice was actually moved away from the table. So if we just get rid of that table and draw it where it now is, when the dry ice is essentially pushed away from the table so that dry ice is being lifted up, well, it's kind of hovering now, isn't it? The dry ice is it's almost floating around, right? And so that's why you can essentially play a game of air hockey with it, because it kind of just glides along, floating on a little cushion of CO2 gas. It's like a little hovercraft. It's its own little hovercraft, really. Okay, so it just glides along quite nicely. Now, before we wrap up this video, I did mention earlier that if you ever need to handle dry ice, you would keep it moving, right? It is possible to touch the stuff. You just need to be careful, right? Something to keep in mind is that temperature is not equal to heat. Wait, what? A Q? Yeah, trust me. Q stands for heat, right? So temperature is not the same as heat, right? Temperature is how hot something is. Heat is the total amount of energy something has, right? So if we look at sort of the opposite, I guess, of the dry ice, a sparkler, right? So we play with sparklers, especially around Guy Fawkes time, if you know about Guy Fawkes. In this country, I don't know when you'd play with sparklers, whenever there's fireworks, which there isn't at the moment because of, COVID, that's the thing. But sparkler, they give off all these sparks, but you can quite happily hold that sparkler in your hand. Here you are, holding it in your hand. All right, you can hold on to it. Those sparks, though, are really, really, really hot. Like really hot, like massively hot, and yet they fall on your arm and you don't get burned. What's up with that? They're really hot, but you don't get hurt by them because they're so, so tiny. So the temperature in this case, the temperature is really high of the sparks, but because the sparks are so tiny, the actual heat content that they have is actually really low. Okay, so you don't damage your arm by these sparks landing on you. Well, if you sort of flip the script on that one, it's the opposite of that is essentially what's going on with the dry ice. It's really, really cold. It will suck the heat out of you, but that doesn't happen very quickly. So if you had a piece of dry ice in your hand, you can sort of juggle it along a little bit, and you don't get into serious trouble unless you stop your hand moving and the dry ice sits on the same patch of skin for a few seconds. Yeah, then it's really going to start to hurt. So there we go. You can actually do stuff with dry ice. Like I'm playing here with my little kids. These are my munchkins. Obviously, I'm not going to let them do something that's really dangerous, right? I did warn them not to touch it, and I had to remind Kian a couple of times, but that's fine. He wasn't touching it, so he was okay.
Don't forget to hit the like button. Yeah. And subscribe to It's Up Here. And here's another video.